In this question, we are given that the function g of x equals 1 over 3 plus f of 2x. And we are given that f of 0 equals 4, f prime of 0 equal 5, and we have to determine g prime of 0. So basically, we have to find the g prime of x and then replace x by 0 to get g prime of 0. That is, we should find the derivative of g of x, which is g prime of x. So first, I'm going to rewrite this given g of x in power form. That is, this can be written as this is an expression under in the denominator. So we write this as a power of 3 plus f of 2x, and this is raised to the power of negative 1. Now this is in power form. We can find its derivative by applying the power rule. And before that, we can also do some substitution here. That is, I'm going to substitute u equals 3 plus f of 2x. And so let's find the derivative of u with respect to x, that is du by dx. And this equals the derivative of 3 is 0, and the derivative of f of 2x is f prime of 2x. We then apply chain rule to find the derivative of the 2x, which is 2. So this basically equals 2 times of f prime of 2x. This is the derivative of u. Now we can rewrite this g of x by replacing the expression 3 plus f of 2x as u. Therefore, this will become g of u, and this equals u power minus 1. We replace this expression by u, and so this becomes u power minus 1. Now we should find g prime of x. So g prime of x, and this equals we apply the power rule to differentiate e power minus 1. So we put the power in front and raise u to the power of minus 1 minus 2. Sorry, it is minus 1 minus 1. And then applying the chain rule, we multiply this with the derivative of u with respect to x. That is du by dx. So let's simplify this. And so this equals this negative 1. We can write this as negative of u raised to the power of negative 1. Negative 1 is negative 2 times du by dx. We can rewrite this as a positive power of u. So therefore this becomes 1 over negative of 1 over u squared times the derivative of du by dx, or the derivative of u equals, we replace by this expression, that is 2 times of f prime of 2x. So it is 2 times of f prime of 2x. Now we should write this as a function of x. So g prime of x, this equals, we replace this u by the substitution equation, that is u equals 3 plus f of 2x. We do the back substitution for u. So therefore we can rewrite this as we have negative 1 times 2 is negative 2 times f prime of 2x. This is the numerator expression. Divided by the denominator expression, we replace u by 3 plus f of 2x. And this is u squared, so this becomes quantity square. And so this is the expression for g prime of x. That is, this is the derivative of g of x. Now we should find g prime of 0. So we have to replace x by 0 in this g prime of x. So replace x by 0, we get g prime of 0, and this equals negative 2 times f prime of 2 times of 0 divided by 3 plus f of 2 times of replace x by 0, and this is quantity square. Now we will use the conditions, the given information, that is f of 0 equals 4. I'm going to copy it here. We are given f of 0 equals 4, and f prime of 0 is given as 5. So this equals 2 times 0 is 0. So this becomes negative 2 times f prime of 0. And this is divided by 3 plus 2 times of 0 is 0. So this becomes f of 0. And this is quantity square. So we have simplified this g prime of 0. Now let's substitute the values which we know, that is f of 0 equals 4. So therefore this becomes negative 2 times F prime of 0 is 5. Replace F prime of 0 by 5. And this is divided by 3 plus, replace f of 0 by 4. Therefore, it becomes 3 plus 4 quantity square. Negative 2 times 5 equals negative 10. And this is divided by 3 plus 4 is 7. So it is 7 square. And so this equals negative 10 by 49. And so this is g prime of 0.